Hello everyone, welcome once again. Today we will be looking at binary compounds and their composition. What is a compound? A compound is a chemical combination of two or more elements. So what is a binary compound? A binary compound is a compound that is formed from the combination of only two different elements or atoms. These compounds are formed through the combination of two distinct types of atoms. The elements involved in binary compounds can be metals and nonmetals or two nonmetals. This gives rise to two main types of binary compounds, ionic and covalent compounds. Ionic compounds are chemical compounds composed of two elements, a metal and a nonmetal. They can also be described as compounds formed from the transfer of electrons from one atom to another. That exists between ionic compounds is called ionic bonds. Ionic bonds can also be defined as the bond formed as a result of the transfer of electrons from one atom to another. In ionic bonding, the metal donates electrons to become a positively charged ion or cation, and the nonmetal accepts these electrons to become a negatively charged ion or anion. The transfer of the electrons between the two atoms creates a strong force that holds the atoms together to form an ionic compound. Let's look at covalent compounds. Covalent compounds are compounds formed from the sharing of electrons between two or more different atoms. As the name suggests, covalent compounds contain covalent bonds. Covalent bonds are formed by the sharing of electrons between atoms. Covalent bonding involves different atoms of the same element or different elements sharing electrons in their outermost shells to attain a stable electron configuration. Examples of covalent compounds are carbon dioxide, CO2, carbon monoxide, CO, water, H2O, ammonia, NH3, and methane, CH4. Molecules such as hydrogen, H2, and oxygen, O2, also consist of covalent bonds because there is a sharing of electrons between the atoms. Let's look at the properties of ionic compounds. They are solid at room temperature. This is due to the strong ionic bonds or forces between the atoms. They have high melting and boiling points. Ionic compounds have high melting and boiling points. High temperatures are needed to break the strong ionic bonds between the atoms of ionic compounds. Solubility in water. Many ionic compounds are soluble in water. When placed in water, the ions separate and disperse throughout the solution. Examples are sodium chloride, NaCl, potassium nitrate, KNO3, ammonium sulfate, NH4, 2SO4, sodium hydroxide, NaOH, Cop2 sulfate, CuSO4. However, not all ionic compounds are equally soluble. Some are less soluble. Examples are calcium sulfate, CaSO4, Lead-2 chloride, PbCl2, magnesium hydroxide, MgOH2, calcium hydroxide, CaOH2, silver sulfate, Ag2SO4, calcium fluoride, CaF2, Lead-2 sulfate, PbSO4. Some are insoluble in water. Examples are silver chloride, AgCl, barium sulfate BaSO4, lead-2 iodide PbI2, calcium carbonate CaCO3, magnesium hydroxide MgOH2. Electrical conductivity. Ionic compounds conduct electricity when dissolved in water. When ionic compounds dissolve in water, the ions separate and become free to move. This makes them capable of carrying electric current. However, when they are in their solid states, ionic compounds do not conduct electricity because they are not free to move. Hardness and brittleness. Ionic compounds are usually hard and brittle. Brittle means they break easily. Examples of ionic compounds that are hard and brittle are calcium carbonate like seashells, magnesium oxide, table salt, etc. High density. Ionic compounds have high densities. This is because they have large amount of ions in a small volume or space. Examples of ionic compounds with high densities are lead oxide PbS, barium sulfate BaSO4, color. Pure ionic compounds are often colorless. However, certain metallic ions can add color to the compound. For example, copper ions can give a blue or green color to an ionic compound. Now let's look at some properties of covalent compounds. They normally exist as gases, liquid, or soft solids. Examples of covalent compound that are gases are oxygen gas, methane, and nitrogen. Examples of covalent compounds that are liquids are water, ethanol, and acetone. Examples of covalent compounds that are soft solids are paraffin wax, sugar, and naphthalene. Their melting and boiling points are very low. Examples are paraffin wax, naphthalene, ethanol, and methane. They can be insoluble in water but soluble in organic solvents. Examples are naphthalene, paraffin wax, fats, and oils. They are non-conductors of electricity in solid, molten, or aqueous state. This is because there are no ions in them. Examples are sugar, paraffin wax, and naphthalene. They have weak intermolecular forces of attraction between their particles or molecules. Let's look at an experiment to show that water conducts electricity. Take note that water is a covalent compound, and covalent compounds do not conduct electricity. So why does water conduct electricity? Water conducts electricity because of some ions that have dissolved in it. This means that pure water, which is water without any impurity or ions, will not conduct electricity. Stay tuned and watch the video that follows. In summary, let's look at some differences between ionic and covalent compounds. Ionic compounds have high melting and boiling due to the strong ionic forces holding them together. But covalent compounds have low melting and boiling points due to the weak covalent forces between their atoms. Ionic compounds are usually soluble in water, but covalent usually insoluble in water. Ionic compounds are insoluble in organic solvents like petrol, but covalent solvents are usually soluble in organic solvents petrol. Ionic compounds conduct electricity when they are melted or dissolved, but the covalent compounds not conduct electricity even when melted. I hope you enjoyed this session. Please download and keep watching the video for better understanding. Subscribe to my channel for more videos. Thank you for watching.